Core objects are the basic graphics primitives that are the building blocks for everything else in a figure window. The functions that create core objects include line, text, rectangle, patch, and image. When these functions are called, you can store the result in handle variables so that you can use the get function to get the properties of the core object and the set function to set or change the properties. The first core object that we'll look at is line. Now line is what is used by the plot function, so what we have here is going to look very familiar. So what I've done is, first of all, I've created x and y vectors where x goes from 10 to 15 in steps of 0.5 and y is the exponential function of x, so it gets very large very quickly. With the line primitive, I'm passing x and y, my vectors, and I'm going to set the line width to 2, so it's a little bit wider than normal and we can see it a little better, and the color to red. So notice the y-axis, how large those numbers get. And I'm going to take the result that I get from this line function and store it in a variable called HL. So HL is now the handle of my line object. Now as long as I leave the figure window open, I can use the get function to get the properties, and I can use the set function to change the properties of this particular graph. Assuming that I still have the same figure window with the line in it, now one way I can modify it is to add text. So text is another one of the core graphics primitive object functions. What it does is it creates a text box in which you can have strings, and you can also have special characters in it that start with a slash. So for example, I say text xy, those are the x and y coordinates of the actual box in which the text appears, and then we have the text string. So here's an example, text x and y. So again, these numbers become very large. So what that is the text is actually in a box, and I'm not going to draw this very well, but the x and y coordinates of the bottom left-hand corner of the text box. So you see the x coordinate is 13 and the y coordinate is quite large. So this actually, again, I'm not drawing this very well, but this actually creates a box in which we have our string, and the string includes the actual characters here, exp of x, and then the slash right arrow gives me a right arrow. There are other slash characters that you can see if you go into the help, slash left arrow, slash up arrow, slash down arrow. There are Greek characters, slash pi, for example. There are lots of different special characters that you can include in the text string. In the previous graph, we didn't actually see the text box, but you can actually see that if you use the background color property and or the edge color property. Rather than putting the actual coordinates using text, there's another function called gtext that allows you to move the mouse to a particular location in the figure window to indicate where the string should be displayed. So this function uses two other functions. It uses the text function to actually create the text box, and it uses theginput function, which stores the x and y coordinates of the position when you do a mouse click. Another core graphics object is called rectangle, and that will draw a rectangle which amazingly can actually have curvature. So the rectangle object brings up a figure window with a unit rectangle. Now some of the more interesting properties that you can set with the rectangle function are the position. So the position is given by a vector that has 4 numbers in it, where the first 2 are the x and y coordinates of the lower left-hand corner of the rectangle, and the third number is the width, and the fourth number is the height. So the default is 0, 0, so the origin is the beginning of the rectangle, and a width of 1 and a height of 1. The curvature is another property. The values range from 0, 0, which is no curvature, to 1, 1, which is a full ellipse. So you can have any number between 0 and 1. So here's an example of a rectangle in which the position is 0.5, 0.5. So if you take this rectangle and you actually sort of extend this. So that would be the point 0.5, 0.5. So again, the lower left-hand corner of the rectangle, if it had a corner, if it wasn't curved. And then the width is 1, so from 0.5 to 1.5, and the height is also 1. Now the curvature in this case, we gave a value of 0.8, 0.8, so it's not a full ellipse, but it's pretty close. So all of the corners are very rounded. And I stored the result from the rectangle function in a variable RH, so that now stores the handle of my rectangle object. So now I could use get to get the properties of it and set to set the properties. The other thing I did here was I used the axis function so that these lines wouldn't end up exactly on the axes. So in other words, you can actually see the entire rectangle. I made the axes go from 0 to 2 in both the x and y directions. Another core object is the patch function. So the patch is used to create a patch object, which is basically made up of polygons, in this case in two-dimensional space. So here what I've done is I've created x and y vectors to store the x and y coordinates of the points that I'm using in my patch. So in other words, I have 3 points or vertices. The first is 0, 0, so this point over here. The second is x is 1 and y is 0, so this point over here. And then the third is 0.51, so this point up here. So those are my 3 vertices that create the patch, and I pass those 2 vectors, x and y, to the patch function and the color red, and you see it fills in the patch with the color red. So that's a simple way of creating a two-dimensional patch. A patch object can also be created using a structure variable that has fields for the vertices and for the faces. Here's an example in which there are 5 vertices, 0, 0, so those are the x and the y coordinates, 1, 0, 1, 1, 0.5, 1, and 0, 1. So I have 5 points in this case. And then the faces shows how the actual points are connected together. So in other words, when I do these vertices, this is the first vertex, this is the second, this is the third, this is the fourth. So it doesn't really matter in which order you do them, but they are in an order. So this says connect up point 1, whatever that is, that was the point 0, 0, to point 2, which is the point 1, 0, to point 4, which was 0.51. So it defines a triangle as that face. And then the second one is connecting up points 2, 3, and 4, and the third face is connecting up points 1, 4, and 5. So we create this structure variable, and then once the structure variable is created, we can pass that to the patch function. So here's a repeat of what we had on the previous slide where we're connecting the points to give us our faces. In this case, there were 3 different triangles. When I pass this structure to the patch function, I set the face color to be red and the edge color to be black. So in this case, we can see the 3 separate triangles. Otherwise, if I didn't set the edge color, it would look like just one large rectangle. We can also do this in 3-dimensional space. So this is just creating x and y coordinates, but you could also create x, y, and z coordinates. So here's question number 2. I've created a simple patch from 2-dimensional points by creating x and y vectors for the points, and then pass those vectors to the patch function with the color green. 2 parts to the question. First is sketch this patch, and the second is show how you could create the same patch using a struct.